The ocean doesn't need an earthquake to become a wall of death. It doesn't need hours of warning or a distant fault tearing open beneath the seafloor. Sometimes all it takes is a single moment, when the land itself gives way. Mega tsunamis are not slow rolling surges. They are sudden, violent, and impossibly tall. They rise out of nowhere, collapse coastlines in minutes, and then vanish just as quickly. And in 1888, in a remote corner of the Pacific, one of these events was triggered not by a massive eruption, but by the collapse of an entire volcanic island. In the Bismarck Sea, beneath New Guinea and New Britain, stood Ritter Island, a steep, narrow volcanic cone rising nearly 800 meters above the ocean. Early descriptions from the 1800s portray it as an almost perfectly symmetrical island, a sharp spike of rock barely more than a kilometer wide. To sailors passing through, it would have seemed like a permanent fixture of the landscape, solid and unmoving. But it wasn't. Volcanic islands like Ritter are built fast and built steep. Layer upon layer of lava, ash, and fragmented rock stacks upward, forming slopes that gravity is constantly trying to pull apart. Beneath the surface, hot fluids circulate through the rock, chemically weakening it over time. Minerals break down, strength is lost. What looks like a solid mountain is often riddled with internal weakness. Over time, the entire structure begins to deform, slowly spreading outward under its own weight. At Ritter Island, that process had been underway long before 1888. Deep beneath the surface, the western flank of the volcano had been gradually shifting, deforming in a way that was invisible to anyone standing on the shoreline. There were no cracks opening dramatically across the surface, no obvious landslides creeping downward, just a slow internal failure building towards something inevitable. Then, on the morning of March 13, that hidden instability reached its breaking point. No one saw the collapse itself. There were no observers close enough to witness the moment the island failed. But across the surrounding coastline, people heard it. A deep, thunder-like sound rolled across the sea. It wasn't like distant waves or wind. It was heavier, sharper, something breaking. Moments later, the ocean began to behave in a way that made no sense. At settlements along the coast, the sea suddenly pulled back. Shorelines retreated. Water drained away from the land, exposing the seabed in places where it had never been seen before. Fish flopped in the shallows. Boats settled awkwardly on wet sand. For a brief moment, everything became unnaturally quiet. And then the ocean came back. The first wave arrived within minutes. It rose quickly, not as a gentle swell but as a steep, fast-moving wall of water. It surged inland, tearing through vegetation, sweeping away structures, and carrying debris with it. People who had been standing near the exposed seabed had no time to react. Those who remained near the shore were caught instantly. But the first wave wasn't the end. It was the beginning. What had happened just beyond the horizon was catastrophic. A massive section of Ritter Island, nearly half of it, had collapsed. Between 4 and 5 cubic kilometers of rock, billions of tons of material, detached from the volcano and plunged into the ocean in a matter of minutes. The western side of the island didn't erode away slowly. It disappeared almost instantly. When that much rock enters the sea that quickly, the water has nowhere to go but up. The ocean was forced upward and outward, generating a powerful tsunami that radiated across the surrounding region. Near the source where the collapse occurred, the initial wave would have been enormous, likely rising to heights well over 100 meters before rapidly spreading outward and losing energy. But even after that loss, what reached the surrounding coastlines was devastating. On nearby islands, entire coastal zones were stripped bare. Vegetation was torn away from slopes high above sea level. Trees were snapped, uprooted or completely removed, leaving behind exposed ground where dense forest had stood just minutes before. In some places, debris was carried far inland, and fish were later found lodged in the branches of trees, evidence of how violently the water had surged. On New Britain, the waves pushed inland for up to a kilometre, flattening everything in their path. Entire villages were wiped out. Homes, canoes, and tools were swept away and scattered across the landscape. Thousands of people were killed in a matter of minutes. And the waves did not stop. They came again and again. Observers described the sea rising and falling repeatedly, with waves arriving every few minutes. Instead of a single surge, the coastline was struck by a sequence of powerful waves, each one adding to the destruction of the last. The water didn't simply flood the land. It surged forward, retreated, and surged again, dragging debris back out to sea before returning with even more force. In some locations, this continued for hours. Imagine surviving the first wave, scrambling to higher ground, watching the destruction below, only to see the ocean pull back again, preparing for another surge, and another, and another. This wasn't just a moment of impact, it was sustained chaos. Even hundreds of kilometers away, the tsunami was still being felt. Waves several meters high reached distant coastlines, continuing for hours as the energy of the collapse propagated outward. Ships at sea reported unusual surges. Coastal settlements far from the source experienced repeated flooding. The ocean remained unsettled long after the initial collapse had occurred. And yet, despite the scale of destruction, the cause of the tsunami was not what most people would expect. There was no massive eruption, no towering ash cloud, no explosive event on the scale of Krakatoa, which had erupted just 5 years earlier. In fact, the volcanic activity leading up to the collapse was relatively minor. There were reports of steam and light ash, but nothing that would suggest a disaster of this magnitude was imminent. No one was preparing for what was about to happen, because the eruption wasn't the event. The collapse was. Modern geological studies confirm that the tsunami was generated almost entirely by the sudden displacement of water as the island's flank failed. The role of any explosive activity was minimal. The real driver was gravity. The moment the structure of the volcano could no longer support itself. And when it failed completely. Today, Ritter Island is no longer the steep, symmetrical cone it once was. It is a crescent-shaped remnant, a curved ridge marking the surviving eastern flank of the volcano. The western half is gone. But it hasn't disappeared, it's still there, just beneath the ocean. Seafloor mapping reveals a vast debris field extending more than 70 kilometers away from the island. Near the source, massive blocks of rock lay scattered across the seabed, remnants of the initial collapse. Further out, those blocks give way to finer material, evidence that the landslide disintegrated as it moved, transforming into a fast-moving debris flow that surged across the ocean floor. The entire event is preserved in that landscape, a record of motion, of collapse, of impact, and all of it happened in minutes. That speed is what made the tsunami so powerful. The faster the collapse, the greater the displacement of water, and in this case, the movement was rapid enough to inject enormous energy directly into the ocean. On nearby coastlines, the evidence shows waves of at least 15 to 20 meters in height, but those are the heights after the wave had already travelled some distance. At the source, where the island entered the sea, the initial wave would have been far larger. There were no observers there to measure it, but based on the scale of the collapse and the physics of how tsunamis are generated, it likely rose far higher, exceeding 100 meters in the immediate vicinity of the landslide. A wall of water forming where land had just vanished, and then racing outward in every direction. This is what defines a mega tsunami, not just its height, but its origin. Unlike earthquake tsunamis, which spread energy across vast distances, landslide-generated tsunamis are intensely local. The most extreme effects are concentrated close to the source, where the displacement is greatest. Beyond that zone, the wave rapidly loses height, but not necessarily its destructive power. For the people living near Ritter Island in 1888, there was no safe distance. The waves arrived too quickly. There was no warning and no time to escape, only the sound of something breaking in the distance, and then the ocean rising against the land. Today, Ritter Island remains in the Bismarck Sea, its crescent shape a permanent reminder of what happened. To anyone passing by, it might look like just another island, just another volcanic remnant rising from the ocean. But it isn't. It is the aftermath of one of the largest volcanic collapses ever witnessed in human history. A place where half a mountain fell into the sea. A place where the ocean responded instantly. And a place that proves something both simple and deeply unsettling. The ocean doesn't need an earthquake to become a disaster. Sometimes it just needs the land to fall into it. I hope you found this as interesting as I did. And as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.